Okay, good afternoon, students. It is February 6th, 2025. We had a delayed opening today and Wacky Wednesday yesterday, and it's a whole lot going on. I'm sorry that you had to find the video on the channel. I just thought it would be way better to get you the paper than to like pass it out at the end of the day. I don't think those things are uh, like effective or helpful, and then papers are everywhere and not everybody gets it. So you obviously use the YouTube link, and here we are. Okay. Let's see. Silly joke. All right. So which triangles are the coldest? And knowing the triangle names is something you just have to kind of memorize, but there are some fun things about them to help you remember the names. Okay. So which triangles are the coldest? They're isosceles triangles. And isosceles triangles have two sides that are equal. So there's a scalene triangle. That means that no sides are equal. An equilateral triangle, all three sides. But an isosceles triangle, two sides are equal. And when I was a kid, I used to remember that because of the SOS and then the ELE. I was like, oh, look, two S's, two E's, two sides, equilateral, like equal, scalene, nothing, no sides. And so you can always classify triangles by their side length and their angle of measurement. So that's pretty cool. Isosceles triangles are the coldest. Okay. All right. So we're going to go over homework for lesson 19. We're still working with decimals and we're multiplying them now. And something I really noticed on our cool down is that we forgot that we can use the standard algorithm for all things multiplication. So we're going to get on that today for sure. What these different buttons mean. It's kind of fun. All right. Okay, so we interpreted and evaluated multiplication expressions. It just means, terms and operations, no equal sign. And so let's look at the different ways that we did that. All right. So we could see 35 times 78 hundredths. One way, we break up the decimal using the distributive property. Look what happens. The 35 stays the same, but the 78 hundredths becomes 7/10 plus 8 hundredths, right? And then we still multiply 35 sets of 7/10 and 35 sets of 8 hundredths. Okay. And we have two products because we probably did this 35 times 7 and 35 times 8. And then once we got the answer, we would then have to place the decimal point. And that's actually where I think that we're having trouble with, because we are not placing the decimal point properly. 4, 5, 6, 7, and 2. There we go. Okay. So let's look at another way. We can do the two non-decimal numbers. We would use standard algorithm for this. And then we would place the decimal point later, which is helpful because it is called place value. And then same thing, we could find the whole number product and then divide by the place value, which means moving the number on the place value chart. Okay. All right. Let's jump into some division up here. All right. So we have 42. I want to know how many 42s. Okay. In 15,330. That's crazy. All right. 42, 42. 42. 42. 420 to 10. Okay, so it's half of 420. Okay. So I have 15,330. Okay, and at 42. I know that it's not going to go into 115, but I can get a number super close without going over up till about 153. And I'm going to use 126. And that is my divide. And it went 3 times. So then 3 times 42 is my multiply. Does McDonald's sell burgers? Now I'm going to subtract. 3 can't, so 4 7, 2, and then bring down the 3, not the 0 at the same time, just the 3. And now I have 273. So I'm going to get a few more multiples here. So if I'm at 210, I'm going to add another 42. I'm going to get 252. And then just for good measure, so I can see if it's 7 or not, 4, not, no, because that's too big. So 294. All right. So I'm going to say that into 273, there are 6 groups of 42. This is a 3. There are 6 groups of 42 without going over. It's the closest we could get, and that is 252. And then I'm going to subtract, and then I have 210, which is 5. Okay, so I have 365. I'm going to check it times 42, and we're using standard algorithm like now and always. 20, 24, 25, 26, 12, 13, 14, 0, 3, 13, 5, 1. Booyah. Okay. All right. Now, getting to know my decimals. Let's write the missing number. I'm just going to kind of notice what's happening here. I think this will really, really help us think through. All right. So on the left, I'm going to find the missing number, and I'm going to do 5. And then you are going to do these on your own. And then same thing, I'm going to do these 5, and you're going to do these ones on your own. Okay, so let's start with the pattern, okay? I'm going to count it out loud because that's the best way for me to understand things. And I'm going to say thousandths, hundredths, tenths, ones, right? Hundredths, tenths, ones, tens, tenths, ones, tens, 100. 100, 1,000, 10,000, 100,000, 10,000, 100,000, 100,000. Sorry, millions. Okay. And then it looks like we're kind of starting here. So on your own, you would have to start at 7 million, then 700,000, then 10,000. Okay. Now let's take this over here. I'm adding and subtracting. I have 5 and 2/10 minus 1. That's 4 and 2/10. This is going to be 4 and 29 hundredths. This is going to be 4 and 296 hundredths. And 7 and 5. Okay. And then I'm just looking for you to work on the top 5 on your own. Okay. So let's look at some more multiplication here. So this is on our exit ticket. Hopefully by now you remember we went over the cool down today in class. I'm going to select all the expressions that are equivalent to this product. So I want to be able to write equivalent expressions. That's highest form of math, when you can recognize and move things into the form that is easiest and quickest for you. So I have 17 times 15. I have no recognition of decimals, so no. I have 17 times 15 and then divided by 100 because this is 1500s. Love that. Yippery. Now I have 1. Okay. I'm going to come back to that one. Here I have 17, and let's see if I broke up 1500ths properly. 1/10, 500ths. Yes, this one works. I like this one. And I like this one. We're going to come back to C, and let's look at this last one. Yep, I can multiply the 2 whole numbers, and then this is also hundredths place, right? Okay, so let's look at this one. This would be 7/10 and 5/10. Let's see if 17 times 15 is 7,500. I don't believe that it is. 8, 0, dust. 7, 1, 5, 15. Nope, it's 255. So this cannot be true. Sometimes you just have to like solve it out. Okay, look at that. Here I did that. I'm going to use E. Okay, and E causes me to multiply, then by the hundredths place. So I know 17 times 15, 35, 5, 8, dust, 7, 1, 5, 15, 2. I know that it's 255, but then I go back and remind myself that this was in the hundredths place. If this is in the hundredths place, then my answer has to have a hundredths place. Absolutely required. So this is the answer. Super fun. I should not have seen any other bizarro, weird stuff happening. You use standard algorithm. That's why we learn it. We use it for lots of things. Okay. All right, let's check this out. I'm going to do 29 times 8. I'm not putting a decimal in my standard algorithm. I don't like that. I'm going to put it on the side. So I'm not going to get confused because I love my standard algorithm. 16, 17, 18, 19, 20, 22, 23. 232 tenths is going to look like this. Awesome. All right. Here I'm going to have 41 times 36 hundredths, or hundredth is. Thanks, Jathan, for always saying that. It's awesome. 624 dust. 312. If you are unable to do the standard algorithm at this point, full stop. You need to get off this video and just practice, practice, practice. All right. So I need this to be in the hundredths place. So that's 2. So I need 76, 14, and 76 hundredths. Okay. Now I have 34 times 74, 6 whole numbers, 16, 12, 13, 28, 21, 25. 7, 2, and then this 74 is in the hundredths place. So that has to be in my answer as well. And it would be this. Okay. So I should see this or this corrected on your paper with the pen. Being able to like do the components, that's part of being responsible. And in 5th grade, like you're definitely capable of organizing your work and being responsible and holding on to the pen that you've earned or that I gave you and earning a new one, right? Okay, the 4 highest scores at the diving competition were boom, 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 boom. What was the highest of these scores? So diving competition probably means like distance. So I'm thinking it's got to be the biggest. And so what is the biggest one? I believe this one is the biggest. Notice I'm always crossing it off after. And I know that 800ths is less than 8 and 1/10. Okay. So it would be 8, 1/10, and 500ths. Do you see how that has more? Yeah, it's good stuff. All right. Ooh, I love this. 1,316 seats, 28 seats in a row. So here's my auditorium, 28 seats. I need to divide to know how many rows, how many rows, how many rows, how many rows, how many rows. 1,316 seats divided by 28 seats per row. Give me number of rows, number of rows. I just realized that Rose, ROWS, is the same sound as ROSE. 1,316 divided by 28. Look at that. 28, 28. And I'm going to make my T chart over here. 16, 4, 5, 28, 56. 1, 2, 3, 4, 5, and 10. 280, 140, 56, 28, 14, 5, 6, 7, 8. 84, 28, 12, 8, 9, 10, 11, 1, 1, 2. Okay. So if I'm looking at 131, coming up on 4 times, that's a dividing. Then 4 times 28 is multiplying. And I know that that's 112. And I'm subtracting. Oops, can't do it, so I'm borrowing. Ooh, 196. Probably going to get pretty close here, but I'm going to continue my multiples. All right, so I have 112, and then I have 140. So I'm going to go to 140 and add another 28, 8, 6, and that would be 6, multiple of 6, and then add another 28. Oh, yeah. I got it. I got 196. Okay. So that means that 7 goes here and 196 goes there. And there are 47 rows of 28 in the auditorium. Okay. All right. And I don't have a lot of room. But I might be able to come back later and well, actually here, 47 times 28, 56, 32, 33, 34, 35, 36, 37, dust, 0 by 14, 8, 9, 6, 11, 13. Ooh, yeah. Right? Here we go. It's all down there. He's really excited. All right. And then this next problem deals with money, which is great. Charlie buys 3 bags of chips. I'm putting a 3 here and 2 sodas. Way cheaper soda place, movie place than anything I know of. The price of each item is listed below. He pays for the chips and the soda. All right. So first we need 3 sets of chips. I'm thinking I'm just going to add these because I can. And I like the marker I'm using. 24, 1, 2, 3, 4, 5. Oh no, 5 down here. My bad. 2, 4, 6. Okay, so this is chips. Okay, and soda, 2.55. Okay, 10, 11, 5, 10. Okay, so it looks like I've spent 6.54 plus 5.10, 4, 6, 11. Okay. And what's left from $20, I do use the 0.00 here. I never do that with multiplication though. So please be aware, but I have to borrow. I need to borrow 3, 8. Okay. So let's see. Charlie will have $8.36 left from $20. And my word problem has a word answer. And that was a good homework. And I really hope you're taking this seriously. You tried it on your own first. You're checking the work. Maybe you didn't like double check by multiplication. So then those are the notes I see in the marker. Either way, love you. Please do your work. We do have a test on Tuesday. Okay. I'm out.